So starting the recording, আজকে আমরা P5 করতেছি কারণ P5 actually অনেকদিন করা হয় না, so it's a good proposition since some of you have exam. Next class ইনশাআল্লাহ আমরা আবার application booklet-এর worksheet continue করব। তোমাদের কিছু homework দিছিলাম, if you have done more than the homework I really appreciate it, if you haven't then you will have to do it eventually, that's the point. 9702 কালকে কখন নিতে পারবো বুকলেট? মোস্ট লাইকলি 2টার পর, টাইমিং ইজ এক্স্যাক্টলি লাইক আর্লিয়ার, বাট আমি এখনই কনফার্ম করতেছি না। আমার এই অ্যাসিস্ট্যান্টের সাথে একটু কথা বলা লাগবে, কারণ মোস্ট লাইকলি আজকে যদি ওদের কোনো কাজের প্রেশার না থাকে, অন্য কোনো সাথে বাইন্ডিং এর কাজ না থাকে, দেন দে আর গোনা গো ফর ডিরেক্টলি ফর মাই জব এন্ড দ্যাট ওয়ে ইট উড বি ইজিয়ার টু অ্যাচিভ এন্ড অ্যাকমপ্লিশ। বুঝছি গেছে? ওকে, আচ্ছা দাঁড়াও। May June 14 52 question number 1 May June 14. So on May June 14 about এখানে থাকার কথা, May June 18 and 17 May June 17 May June 16 14 May June 14 52 আচ্ছা May June 14 52 question number 1. এটা কি আমরা ডিসকাস করছিলাম না? আচ্ছা I'll go for it anyway. এটা না? May June 14 52 question number 1. May June 14 52 হ্যাঁ ঠিক আছে এটাই। So let's have a look at this question and have a grab at it. So questionটা খেয়াল করো। You also have your paper in your hand, so you can turn up your own paper as well and read it from there as well. No big deal. It works equally fine. The question says the two identical coils are connected together and arranged as shown in figure 1.1. Two identical coils, important information, which means we have the same number of turns, we have same thickness of wire, they have the same diameter and everything, identical coils. The coils are in vertical plane and are parallel to each other. When the coils are connected to a power supply, there is a magnetic field between them. It is suggested that the magnetic flux density B of the field at point X is related to the radius R of the coils by the relationship B equals to 0.72 mu naught NIR, where N is the number of turns on each coil, I is the current in the coils, and mu naught is the permeability of free space. Design a laboratory experiment that uses a Hall probe to test the relationship between B and R and determine a value for mu naught. You should draw a diagram on page 3 showing the arrangement of your equipment. In your account, you should pay particular attention to blah, 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 blah. Okay, fine. So the question says specifically, it is suggested that the magnetic flux density B of the field at the point X is related to the radius. So they have already helped us in this question that they have already given us two specific variables which are supposed to be related to each other. So magnetic flux B density B, that is related to the radius of the coil R by this relationship. So B is the dependent variable and R is the independent variable. It goes to basic. What are the control variables? এখানে বাকি যা কিছু আছে সবকিছু control variable. Number of the turns in the coils and also the current flowing through the coils is also control variable. We have to keep, or you can say that we have to keep these things constant for each individual reading. Basic idea টা হচ্ছে যে আমরা different radius এর coil pair use করতে হবে and we have to have at least 6 set of them. So we are talking about 12 coils. One pair is identical to each other, and we should have at least 6 set of them because we usually take 6 set of data. And in all of these coils, the number of turns in these loops should be exactly same, and the current flowing through these coils should be also exactly the same, which means number of turns can be very easily controlled because you can count how many turns you are going through and you can have a manual count. So that's not a very big deal, but you have to mention it that we make while turning the wires onto the coils, or you can say in these ribbons. It's a ribbon না এগুলোর কি বলে? এই স্ট্রাকচারগুলোকে কি বলে? Bobbin. Do you guys know what these things are called?
Sir, we discussed a similar thing before. Similar question.
We discussed a similar question, but not this exact one. That earlier one was, I remember that earlier one was not this exact one, but I took some reference from this one. But since someone proposes, so I'm going to go for a detailed version for this whole thing. A loop, I'm going to use the word loop. So We can count the number of turns we're going to place into the loops whenever we're going to want the wires. That's okay. But to make sure that we control the value of the current I in both the coils same, we need to have an ammeter connected in series, and we also need to have a variable resistor. Mamun, তোমার সাথে আমার কাজ আছে? Hold on just a second. Oh, yeah, resume recording. To make sure that the current flow remains the same for all of our readings, we have to make sure that there is an ammeter connected over here, and also there should be a variable resistor connected in series with the supply, so that by controlling the variable supply, we can control the current value as well. So before we take every reading, we have to make sure that the current value is same throughout our experiment for each of the individual readings. It has checked apart. For repeat and average, one thing is very obvious, that we have to make sure that what are the other variables which might be relevant for this case. What I believe is that the distance between the two coils is also very important, because if you make the coils get closer to each other, that is going to give us a much stronger magnetic field, and vice versa. So the distance between the coils should also be a control variable, although this is not involved in the equation, but this should come up as a control variable. So I would prefer that you mention that as well. Even if you forget about this variable when you're writing in the first place, and you remember it somewhere later, you can also write in the place that while doing all of our readings, we make sure that the distance between the two coils are kept constant. Even if it's not in the very first paragraph, if you write it somewhere in the later part, and if you're supposed to get a mark for that information, if there's a compulsory mark for the information, you can still score that mark in that location, no big deal. Otherwise, just a second. Another thing is that we have to somehow make sure that these coils are perpendicular and vertical to each other. So we can take help of some stand and clamp mechanisms, and you can draw the apparatus setup of this thing over here. Another thing that is quite important, that you have to mention that how are we going to measure the radius of these coils. So we can use you can say that we can measure the longest distance on the two sides of the coil, and measure that in multiple elements, and then find out the average, which gives us the diameter divided by 2 gives us the radius. We should measure the diameter in multiple locations. That's very important for you to mention, because how do you measure the R has to be mentioned in your formula as well. And also, finally, how are we going to use the Hall probe to measure the magnetic flux linkage over here? The Hall probe should be preferably placed in the location X, which in this case is a floating point, but it doesn't have to be a floating point. We can keep a Hall probe exactly at the midpoint between the two things. So what we're going to do, we're going to use another set of stand clamp to place the Hall probe over here, and and we can find out the position of this X position physically. One of the easiest ways is that we can tie up 2 pieces of strings, very thin strings, non-metallic strings, very important, cotton strings, from this point to the bottom and from this point to the bottom. So if we do this kind of 2 diagonal strings, the crossing point would give us the perfect midpoint. And this would pretty much always be the same, but we have to make sure that the distance between the two coils are kept constant for all the readings, and also the midpoint can be very easily detected. In your diagram, it's very important that you show all the positions of the clamps, and stands, and the vertical measurement, and everything else as well. Making sure that the two coils are parallel to each other can prove to be a bit difficult, but if we use multiple clamps which is going to hold these 2 set of coils, we can pretty much achieve it. One precautionary thing that can be mentioned over here is that, sorry, before I go for the precaution, in the process of method of data calculation, one thing is very important, that whenever we are using the Hall probe over here, we should take the Hall probe reading in the orientation for which the Hall probe gives us the maximum reading. And after we take one set of reading, we should rotate the Hall probe by 180 degree and take another reading and take the average of those 2 things. If you wonder that why should we rotate, the idea is very simple. We're gonna first hold the Hall probe in the defined location and move it around to get the most appropriate or most optimum alignment, so that the magnetic field lines cut across the Hall probe coil perpendicularly, as perpendicular as possible. But it is very difficult to make sure that we are going to achieve this by 100% every single time. So if we just reverse the Hall probe and get another reading, that can give us that can compensate for the misalignment that you might have had in the first reading. So this is a bit important thing. We're definitely going to work with the magnitudes. We're not going to use its sign. So even if your whole proof gives you a plus or minus value, you can disregard that thing. So whatever the numbers you get in, I mean, for ideal scenarios, these two numbers are supposed to be equal. But if they're not equal, you are gonna have those collected and have the average to measure the magnetic field strength for that set of reading. One other thing is that for the precaution part, important bit for the precaution is that since we're going to work with coils of wire and we're going to have some significant current, if the length of the wire is quite small and the thickness of the wire is not that large, then there is a possibility of significant heating in the coil. So we should preferably keep the current value flowing through the coil pretty small to begin with, so that we do not have too much heating in the coil. Yet the current value has to be strong enough, or we can increase the number of turns in the coil so that we can have a significantly strong value of magnetic flux linkage, not too few turns, like 2 or 3 turns. No, preferably go for, let's say, 10-20 turns, so that you can have a large resistance. So that will necessarily limit your current, which is a good thing, and bigger number of turns will also give you a much stronger magnetic field strength, which is going to be easier to measure because of the limitation of the Hall probe mechanism. So that's a very important thing, that having a large number of turns will help us do the experiment better. And just because I mean, but even if so, I mean, whenever you're doing it for the first time, let's say for the first set of reading, if you're not very careful and if there is a possibility for high heating for the coil or the wire apparatus, wearing safety gloves to avoid heat injury or burn injury can be mentioned as a human safety for this. I cannot think of another human experiment for this, because we're not working with very high voltage, so shocks are not prominent. The only possibility is burn damages from the heating of the coil. I don't see any other burn damages. And the later part is pretty simple, that you know how the analyzing part goes by, that you are gonna have all the values there recorded, and eventually you're gonna plot a graph of B versus 1 by R, because in this case R is at the bottom. You plot a graph of B versus 1 by R, and then you have to mention that if the graph produced is a straight line that passes through the origin, then we can say the relationship is valid. The gradient equals to 0.72 mu naught Ni. N and I are calculated and recorded from our experiment for each of the reading. So mu naught equals to gradient divided by 0.72 n into I. That whole thing goes at the bottom. So you just have to mention how you're going to calculate the mu naught, because the question asks you to give that mechanism. That's pretty much it. If you ask me, that's pretty much all I can think about to go for, including all the safety precautions and everything, or the additional details. I cannot think of anything else. A couple of things that we can get that can also be mentioned, that while we are winding the wires while we are making the coils, we can be careful not to make the wires overlap, or they should be placed side by side parallel. It's not very imperative, but that makes a much better winding procedure, because that's how the figure proposes it should be done. Anyone else want to propose anything else, any other process or part of the experiment that you think that I missed? I'd like to hear about this. Abez, you raised your hand, then you dropped your hand. I believe you got your question answered. Yes? No? Yes, Asadul, bolo.
স্যার ডায়াগ্রামটা মানে কি ইনক্লুড করতে হবে এটা একটু একবার বলবেন আমাকে?
আমি একটা স্যাম্পল ডায়াগ্রাম এঁকে দেখাই. For example, I might be wrong. Actually, before I go for the sample diagram, it would be a good thing if I go for the mark scheme. আচ্ছা, আমার জন্য মার্ক স্কিম অ্যাকচুয়াল মানে ওয়ার্ড স্টাফস থেকে বের করাটা ইজিয়ার, বিকজ what is this? This is not supposed to be here. দেখেন আচ্ছা, চলে আসছে. Never mind. এক মিনিট, এটা হচ্ছে কোন ইয়ার? মেজুন 14. মেজুন 14 আছে হচ্ছে কোথায়? টিউটরিং ম্যাটেরিয়াল S14 970 মার্ক স্কিম 52 না, এটা 52 মার্ক স্কিম 52, also examiners report 52. So let's go look at these two things, and then I might as well show you the possible drawing of this thing. But let's have a look at what they have for us. Planning: R is the independent variable, B is the dependent variable, or vary R and measure B. Keep the number of the turns of the coil constant. Do not accept same coil. Keep the current in the coil constant. So they haven't mentioned the distance, but I would highly go for this. I think they have mentioned the distance in this thing. So we're gonna go for here eventually. So I mean, method of data collection. Diagram shows flat coils and label Hall probe position at X. Minimum 2 levels needed. Solenoids will not be created. Solenoids will not be created. Solenoids will not be created. What does that mean?
You shouldn't draw solenoids, sir. That's what they say. Like you shouldn't draw a tube through which you wrap the coil the wire around.
We're gonna label coil, and as long as they can they do become a solenoid, and they're gonna produce a magnetic field anyway. So what's the big deal?
I know, sir, but they gave a prerequisite diagram.
I think what they are trying to mean is that in your description you better not write the word solenoid. Stick to the term coil. I'm not sure why that is a important factor over here. I really don't know, but there might be a good reason for this, but that I do not know. But you can see over here that solenoids will not be created. So prefer to stick to the term coil rather than writing solenoid. I think that's better. Then it says workable circuit diagram for coil connected to DC power supply and ammeter. Do not allow AC power supply in your circuit diagrams. Obviously, we are going to have DC because we're going to produce a DC coil. Connect the Hall probe to the voltmeter or CRO. Allow galvanometer, but do not allow ammeter. So you have to connect the Hall probe to the voltmeter. Yeah, I forgot about that. I'm not going to get this mark. I forgot to mention this thing. Hall probe, as per your syllabus, is not the device that is going to give you the voltage output directly. As per your syllabus, Hall probe happens to be the only coil that produces the voltage across itself, but it doesn't measure it. So you have to connect the Hall probe inputs to voltmeter or what is this thing? Cathode oscilloscope, and be able to measure the voltage output of the Hall probe from that secondary measurement device. That's what you have to do. So you have to mention that as well. I mean, just I always assume that the Hall probe is a built-in device, like a multimeter that you're going to hold in the place, and in the digital display, the voltage is going to pop up. That's somehow always is my mind setting, and this is something that is not applicable for your syllabus. So remember that you have to connect the Hall probe connections to the voltmeter. This is something that I forget, but you shouldn't. Be careful. Then measure the diameter radius of the ruler or the vernier calipers. Do not allow a micrometer. Well, obviously there is no point of measure the radius. Measure the diameter, and which is going to lead up to the radius, the ruler or vernier caliper. So you should mention that it measured in multiple places for the maximum length. Calibrate Hall probe with a known magnetic flux density. This is something that I would not also mention. Calibrate the Hall probe with a known magnetic flux density. Why is that a method of data collection? Shouldn't this be a safety precaution? Weird.
Like, sorry, you have to, in a known magnetic field, you find the voltage and you draw a graph. And from the graph, you interpolate the things and you find the magnetic field flux density from that.
Yeah, that's okay. What they I don't I trust English key. Disagree. I do not disagree with the term that we have to calibrate the Hall probe with a known value of magnetic flux density, because essentially it's necessary for proper measurement of the variable that we're trying to measure. But why should that be included in the method of data collection? Shouldn't that be more of a safety precaution, or maybe more of an additional detail? Like if you're trying to measure the diameter of a certain object by using a micrometer screw gauge, being careful for the zero error or backlash error. Does this belong in the method of data collection? In my opinion, in my head, in my understanding, no, but they have mentioned it over here. Yeah. So
if you don't do this, you can't really find the magnetic flux density. You can
right. No, sorry. Yes, definitely. Sure. Once again, the problem that I'm thinking about is that I am assuming that the Hall probe is going to give you the B value in the digital display, but it's not supposed to do that. Hall probe is going to measure the voltage, which is going to be fed to the voltmeter. Voltmeter is going to give you the voltage value, but not the magnetic flux density. So you have to now convert that voltage information that you're going to measure from these devices, voltmeter or CRO. You have to convert that voltage information into relevant magnetic flux density information. That's where the calibration comes in. Yeah, obviously it makes sense now. My bad. Yeah, it's important over here because as per this method of data collection that we are mentioning, this Hall probe is going to give us a voltage. We're going to measure that voltage using a voltmeter, or we're going to connect it to a CRO and we're going to measure that up. But somehow we have to convert that voltage information into relevant magnetic flux density information. So we have to have a calibration curve, or we have to have some sort of equation, graph, you name it. Some sort of calibration should be there so that we can convert that thing to that thing. Makes sense. Abhias, thank you. Thanks for helping me understanding that. Really grateful for it. Method of data analysis for a graph of blah blah blah, mu naught equals to gain by eta. It allows precipitation linked to large current heating of coil. Example, switch off when not in use, or avoid overheating coil. Do not charge coil because it is hot. Okay, so it's all about heating. So you just yeah, beautiful. Additional detail. 11 points might include altogether 4 marks out of it. So typically you can see over here that in some cases the additional detail have 6 marks. In some cases in this question they have 4 marks, because you can see one of the marks that we have got is over here. Typically the planning part, defining the problem, usually have 2 marks in it. Like you mentioned, the independent dependent variable goes 1 mark, and the constant and the constant variable to not you know independent variable, that is dependent variable, that is key variable jano something that you have to keep constant. Control variable, exactly. Yes, thank you. The control variable usually scores the second mark, but in this case we have 2 control variables. We have to so that's why we lost 1 mark. So আমাদের ওই 6 মার্ক থেকে 1 মার্ক এখানে ঢুকে পড়ছে, and বাকি আরেক মার্ক আসছে হচ্ছে মোস্ট লাইকলি 1 2 3 4 5, বাকি আরেক মার্ক কই গেছে আল্লাহ জানে। মেথড ক্যালকুলেশন সবসময় 5 মার্কই থাকে, মেথড অ্যানালাইসিস সবসময় 2 মার্ক থাকে, সিম্পলিফিকেশন 1 মার্ক থাকে। সো 1 2 3 4 5 6 7 8 8 9 10 11. আচ্ছা, anyway, I might be wrong. Additional detail এখানে 4 marks আছে। দেখি কি বলছে। Use a large current or large number of turns to create a large magnetic field. We talked about this. Use a resistor to adjust current in ammeter to keep the current constant. You need both of these things to make sure that your current is kept constant. So ammeter is for observation, resistor is for controlling. Hall probe at right angles to the direction of the magnetic field, so parallel to the coils, allow adjust to obtain maximum reading. So you have to mention that. So if you don't mention this part, if you just say that we're gonna rotate the Hall probe till we get the maximum reading out of it, then you also get the same mark. So it doesn't have to be exactly these words, but if you write this thing that we trial and error to get the maximum reading, you also score the same thing. Reason method to keep the Hall probe perpendicular to the direction of the magnetic field. Example, use a set square, fixed rule, optical bench, or equivalent. So I did not mention a mechanism for how we're going to keep the Hall probe over here. I said that we're going to use as stand-on clamps in the position, and we're going to find out that position by the use of 2 diagonal strings. So reason method. So whatever you are proposing has to be logically achievable. It shouldn't be something like the Yoda using force or something. That's not acceptable. Method to check coils are correctly aligned in parallel. Method to check coils are correctly aligned in parallel. Yeah, this is something that I said, that the coils, the gap between the 2 coils should be made sure to be equal in all the places, which you can do by multiple iterations of checking. Repeat measurements of D or R and average. Yeah, we talked about this as well. You should validate the graph is straight line match to the origin. For a private graph, do not allow a computer method. Yeah, I think it pretty much makes sense. Now, as for the diagram, let's have a look at the examiners report. Holy crap, examiners report is big. I have to read this whole thing. Sure, why not? Ideas can help. This is one of those questions which can actually make a lot of your idea generation. So let's go for it. My monitor flickers and my cat shouts. Candidates were required to design a laboratory experiment to investigate how the magnetic flux density B in the center of the 2 parallel coils varies with the radii of the coils, and to determine value of constant mu naught. The initial marks were awarded for correctly identifying the independent and the dependent variables. Many candidates correctly realized that the radii of the coils was the independent variable and the magnetic flux density was the independent variable. Some candidates searched varying the distance of the Hall probe from the coils. Okay. Key. Some candidates searched varying the distance from of the Hall probe from the coils. Okay, this is wrong. This is wrong. Further care is then available for controlling variables. Candidates should how a fair test can be carried out by keeping appropriate variables constant. As has been indicated in previous reports, it is expected that candidates will explicitly identify the variables that need to be kept constant. Controlled is not an acceptable term. alternative to the word constant. Okay, yes. Control is not an acceptable alternative to the word constant. This is very, very important. Words, people, keep this constant. Keep this variable controlled, not the same thing. Be careful for the choice of your words. In case of gradient was available for keeping the current constant and keeping the number of turns in the coil constant. Stronger candidates were able to score an additional mark for describing clearly the method to keep the current constant. To gain this mark, candidates needed to indicate a method for changing the current using a rheostat and a method for checking the magnitude of the current using an ammeter. Beautiful. 5 marks are available for the method of data collection. Candidates were expected to draw a label diagram for this investigation. Circuit diagrams must be correct and clearly labeled using conventional symbols. Incorrect diagrams often omitted the correct position of the Hall probe at the center of the two coils. Correct diagrams should have had an ammeter to measure current. A significant number of diagrams indicated incorrectly an AC power supply or had voltmeters and/or cathode oscilloscope in series with the power supply, which is highly wrong. This should be two different circuits. One circuit producing the energies in the two coils, and the second circuit connected to the Hall probe and leading to your voltage and consequently the magnetic flux linkage measurement. These two circuits should be entirely different and disconnected from each other. There is no relationship for these two circuits. I'm going to show you the diagram in a bit. Hold up. Some weaker candidates do a large current circuit or containing the power supply connected to the coils and the Hall probe. Some weaker candidates do a large circuit containing the power supply connected to the coils and the Hall probe. Oh, I mean, they connected everything together. So they made a hodgepodge of the whole thing. Weaker candidates, yeah. So large circuit in this case doesn't mean that it's volumetrically large. It means that it had all the components connected in a single circuit. That's what they mean. To investigate the relationship, candidates needed to indicate how both the output of the Hall probe and the radius of the coils could be measured. A large number of candidates stated that the Hall probe would be connected to a voltmeter or cathode oscilloscope, and this was sometimes indicated on the diagram. Most candidates were able to suggest either a ruler or vernier calipers to measure the diameter of the coils. A micrometer was not given credit because it's not logical. Candidates could have gained an additional mark for repeating the measurements of diameter and finding an average. Candidates could have gained an additional detail mark for repeating the measurement of diameter and finding an average. Acha, I buchi. Within the methods of data collection, candidates should also include additional detail. Credit was given to candidates who suggested the use of a large current and/or large number of turns so as to increase the strength of the magnetic field. Other additional detail marks were available for keeping the Hall probe at right angles to the direction of the magnetic field and describing a method to ensure that it was perpendicular. Hold up. Other additional detail marks were available for keeping the Hall probe at right angles to the direction of the magnetic field and describing a method to ensure that it was perpendicular. Okay. There was also a mark available for repeating the measurement of B with the Hall probe reversed and finding the average. This is something that I talked about. You're using a Hall probe, you have to make sure it's perpendicular. It's difficult to make sure it's perpendicular, so you reverse it by 180 degree, get the second reading, and do the average. Yeah. Candidates could also have gained credit for explaining how the coils were checked to ensure that they were parallel and aligned. Again, detailed explanations are needed. So detailed explanations are needed in this case. It means that you have to say that while doing the experiments, we measured the distance between the two coils in multiple places along their periphery, and made sure that the coils are equidistant in all the locations / parallel from each other. There were 2 marks available for the analysis of data. It is expected that the candidate should say that the quantity should be okay, fine. There was 1 mark available for describing the appropriate safety precaution. Candidates should be encouraged to give clearly reasoned safety precautions that are relevant to the experiment. Candidates were expected to describe a safety precaution related to the hot coil. Candidates who mentioned electrocution or burning due to the wires were not awarded credit. Yeah, electrocution is not going to happen over here because we are doing our experiment with a DC supply with a very significantly low voltage, so you're not going to get electrocuted. I mean, that's just not going to happen. For worst case scenario, you're going to get feel the heat of the temperature, but the resistance of your skin is too high for DC voltage to pass through. So electrocution is just not good. So they said the candidates who mentioned electrocution or burning due to the virus were not carried. So burning was also not a carrier. So I actually mentioned this burning part for my safety precaution, but as far as these people are as far as the CAP is recommending that burning is not also acceptable. So they are only proposing that the heat generated in the coil would only pose a problem to our to the effective data obtained from the experiment. So burning in this case is also not allowed, but Okay, you can live with that. Okay. Candidates who mention electrocution or burning due to the wires were not allocated, which means that even if I mention that I have to keep the current minimum so that the heat generated in the coils are low to avoid burning, if you just mention the word burning, I'm not going to be awarded the safety mark. So this is just, well, this is a bit harsh. I would not get this mark, but okay, I'm learning. So candidates who mention electrocution or burning due to the wires were not awarded KD. So in this case, burning is not a prevalent issue. It must be emphasized that those candidates who have followed a hands-on practical course during their studies are much better placed to score these additional detail marks. It is essential that candidates' answers give detail relevant to the experiment and question rather than general textbook rules for working in a laboratory. What this last paragraph is about is that in your paper 5, in your A2 syllabus, we should not skip any laboratory courses. We should make you kids do these laboratory experiments hands-on, so that you have your actual understanding for how these things are done, so that you could actually produce this information in a much better quality while you're writing about those. This kind of theoretical practice that we are doing right now is not something that is recommended. Tough world, tough world. Okay, so if I now try to show a bit of an example for how to draw the diagram, I'm going to try to do that.
Sir, do schools show physical demonstrations of these experiments?
None that I know of. None that I know of. So, yep. And then we're gonna draw some vertical lines representing the coils. Hey, 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 hey. My kid is here for a couple of days, and I came to understand that the kid is asleep is one of the sweetest information in the world. That's my cat. Okay. These are the coils. I would prefer to set them up, and then we should have some additional stuffs. Coil comes in, this is supply, plus minus, a bit of a switch, rheostat, ammeter, coil comes in, coil comes out, circuit closed. So that's one circuit, and then I would appreciate that you now start drawing the stand and the clamps. So here's a stand, there it goes up, there is another stand. You don't necessarily have to show the table. I can skip drawing the table, but in some cases drawing the table is also a good idea. Show multiple clamps that they're connected with the wires, multiple places, and the Hall probe is located over here. If I was doing this experiment, I would definitely go ahead and draw these two pieces of strings. And I'll also mention that these are the two strings used to find out the midpoint. So let me choose a bit small thickness. I would actually draw them on the figure because I would include that in my diagram. Wow, my rectangle was actually spot on the middle point. Good, good, very good. This is X. There's a rectangle over here. So this is your Hall probe. And two wires should come out of the Hall probe thing. And this wire should be disconnected from the original circuit. So you can see these are overlaps because I'm not going to give any nodule over here. So connect this thing to the, you can draw the voltmeter or you can draw the CRO. If you write the CRO, you can mention a bit additional detail for the CRO, but you can see in this additional detail, there was no additional mark given for the CRO calculation. So might as well mention the voltmeter only. or we can write CRO, and how to hold the Hall probe in its place. That can be drawn with an additional clamp, but that clamp that we're going to show up over here should preferably stop over here and then start over here, because this clamp is gonna travel to the hollow space of the reels, and then you can show another clamp over here just to hold this thing, or you can show other clamps over here. Now you have to do the labeling. So these are the circuit symbols. You don't have to label the circuit symbols. So I have labeled this here already: stand, clamps, coils, Hall probe. What else can I draw? Coil, wires, diameter. I don't have to measure the distance between these two parts. So to make sure that these things are perpendicular to the table, I can also try to draw some set squares, because that was a relevant information. So you can draw up a set square over here, proving that you are making sure that the coils are all perpendicular. So that also can score you some additional mark. Why not? I need to flip this. How can I flip this? Okay, I have to flip this with magic. Flip horizontal, transparent selection, boom. So something like this can work. I think that's pretty much it. Anyone else would like to propose something else, some addition to this diagram? I'd like to hear. Yes, Abiyaz or Asadul, or anyone else.
Sir, should we mention that the clamps or holders, they shouldn't be metal? Will that interfere anyway?
That would be a very good idea. Although they haven't mentioned this thing in this part. I mean, not being metal is not the primary thing. Not magnetic is the primary thing. I mean, if you can manage to achieve some, let's say, brass setup, that you can use as well. Those are pretty rare but achievable and pretty uncommon. But if you go for plastic, that's actually much better. You can directly mention that we're going to use plastic stands and clamps so that it does not affect our magnetic field strength. Mention the material.
So, sir, I checked out that that thing you gave, the guide by that Pakistani man, Tariq Jawad.
Yes.
And he drew a optical bench. Did the examiner report mention anything like that?
For this question?
Yeah.
No, we haven't seen anything about the optical bench.
He drew an optical bench with adjustable knobs.
An optical bench can be useful because optical benches, I mean, have you seen the optical bench? Having an optical bench for this experiment is not essentially necessary, but having an optical bench might actually be helpful because of one thing. Let me show you. It's not essential for this experiment, so you don't have to incorporate an optical bench. But if you consider the structure of an optical bench, this is how an optical bench looks like. So you have a lot of clamps and you have a lot of holders in between. So it's possible that you can clamp your coils with these holders, and by placing them left and right, you can keep the distances pretty even. And achieving this experiment, you can use your Hall. You can have your Hall probe sticking up from one of these probes. You can have your coils sticking up from one of these probes. So I mean, arranging the apparatus setup with a optical bench can prove to be a bit more easier because we have a lot of stands built up within this setup, other than doing this on a flat table surface. But if you want to do this on a flat table surface, let's say something like this, why not? Make sense?
Yes, sir.
Sure. So, Asadul, drawing বুঝে গেছে?
Optical bench use করলে আমরা কি just এরকম লাইন দিয়ে ওই হোল্ডার্স গুলো শো করলে হয়ে যাবে?
If you want to go for optical bench, you should mention in your diagram that you're going to draw an optical bench. In that case, you're going to need a flat line over here representing the ruler or the platform of the optical bench, and each of these things should be placed on a single piece of rectangular column representing one of the clamps of the optical bench. That can work as well. But your description of the method of data collection and also the apparatus setup should revolve around that equipment. So you should mention that how we're going to stabilize the equipment and how we're going to take measurements of the optical bench. You should, those things should be involved, but it is equally acceptable. Yes.
জি স্যার, বুঝতে পারছি, থ্যাংক ইউ।
No problem. So that was a pretty detailed one. I tried to be as detailed as possible for this question, and then let's pick up a next one. From here we have 970-251 ON13 question number 1. ON13. Boom. W13. Oh no. 51. So we're gonna need this. Close everything else. We're also gonna need the mark scheme. ER 51, MS 51, MS 51, MS 51. All right. Question number 1. Let's have a look. Nice question. Raya, nice questions. You have gone for the military questions. Yeah, these are good questions because these tend to be pretty what can I say, mind blasting. It will blast your mind. An aluminum ring is placed on a coil with the rod of a metal retort stand passing through their centers as shown in figure 1.1. Okay. When an alternating current of frequency F is applied to the coil, the ring rises until it is in equilibrium at a height h above the coil. It is suggested that the relationship between h and F is this. So we have an alternating coil at the bottom. The coil is producing a solenoid, so it has two insulated wires producing a magnetic field, and it is producing an AC, energized by an AC supply, so it is continuously flipping back and forth. Relationship between H and whenever we're going to energize this coil, the aluminum coil, this aluminum ring, which is not connected anyhow with this coil, not electrically, not physically, it is just placed onto this thing, and this is going to rise up to a height over here and become stationary or stable at a height over here. Okay, and the alternating current of the frequency F is the important factor. So this is that value. It's such that the relationship between H and F is given by this relationship. H equals to K, F to the power N, where K and N are constants. To elaborate extent to study the relationship between H and F. And determining your values for K and N, you should draw a diagram on page 3 showing the admin of your equipment. In your account, you should pay particular attention to blah, 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 blah. Achha, the first thing is that you might wonder, although it's not necessary for this for you to answer this question, that why should the aluminum ring jump in the first place? Anyone has a good idea about this? It's an aluminum ring. It's not a metallic. It's not ferromagnetic as well. So can anyone guess, or do you have any idea? Speculation even, right or wrong, doesn't matter. Just share with us.
Lenz's law. মানে কাট করার জন্য it will try to produce an opposing magnetic field.
But why would that produce magnetic behavior? Because in this case, the aluminum ring going up and staying up means there is a continuous repulsion between the coil and the aluminum ring. So how does Lenz's law brings up here to make sure that the aluminum ring is magnetized the opposite pole of the coil? I mean, how does that work? Do you get my question?
Research চিন্তা করছে.
Yes, think about it. Think about it. It's a good one. I'm not also sure about this thing either. We're gonna send this thing, and that's gonna produce this thing. So The electrons in the aluminum coil. Does this have anything to do with eddy current? The electrons. No, I honestly don't know how this is levitating, but it is gonna levitate somehow. Let me just find out a possible reason. What I'm searching for right now is not relevant to your P5 question, not for this question. I'm just trying to go find out the science behind why this thing is possible.
Sir, on the messenger group, I posted a thing of the experiment, a video.
Is lensless demonstration? Okay, I might as well pause the recording. As you've seen the demonstration a little bit earlier, that which was found by a simple YouTube search, is that for this experiment to work, this central shaft has to be ferromagnetic, which means it has to be made from iron or basic iron, which should work better. So it says that, so we are trying to achieve this. So how can we do this thing? In this question, H is the dependent variable which you're going to measure, and the frequency of the offering supply is the dependent variable. So we have to have ways to measure these two variables properly. Now we have seen that whenever this coil was hovering, it was not essentially becoming stable. It was actually equilibrium, and it was a bit jumpy and stuff. So we might as well prefer to measure heights in multiple sides and get an average of this thing, so that we do not mess up the height value. That's one thing. And also we are trying to measure the height from the. If you have a look at this thing, if I zoom in, you should see that. Take a good look. We are measuring the height from the bottom of the ring to the bottom of the ring, so that we are actually measuring the actual height jumped by this coil behavior. That's one important thing. And also the coil. So that's how we can measure the H, by using a basic meter rule. But we have to take multiple measurements and do the average. And the other thing is that we have to achieve this thing by changing the frequency of the alternate AC supply. So if you're willing to have a variable frequency AC supply, we have to use a device which is called a signal generator or a pulse generator. They pretty much are the same thing. I mean, their working can be quite complicated. I honestly don't know their total working, but what I can tell you is that these things. This is basically like one of the power supply units that you have seen in my lab. For those who have done experiments, is you just plug it into your basic wall socket, and then you can turn up some knobs, or you can have some digital buttons to go make up and down to change the output frequency of the supply. So there is a mechanism by which you can change the frequency of the supply, which is going to come out of that device. It can electronically change that value, and we're going to use one of those. Typically in the signal generators, there is a display which tells you the actual value of the frequency of the output. So it is very much possible that you can read the value of the frequency of the AC supply from the signal generator device. Alternately, one thing that we can also do is that we can connect the supply in parallel with the CRO. In the CRO, we should be able to get the exact sine curve of the forwarded supply, and by knowing the time-based value and the gap between the two crests or two troughs, or basically a period, we can calculate the exact frequency of the supply as well. So it can work either way. You can directly take a read off from the signal generator, or you can take connect a CRO and take the measurement of the frequency. You measure the time period, and then you reverse the time period to get the frequency and write that into appropriate words, set of words, so that it's understandable. So these are two ways you can measure H and F. So these are the basic way of data calculation. And what other things that we're going to need? First of all, one thing, we have to make sure that while we're taking the measurement of the using the meter rule, we have to make sure the meter rule is perpendicular to the ground. So we have to mention the use of a set square. You can draw it on the figure. If you don't want to draw it in the figure, you can you have to write in detail about the use of the set square in your diagram. And safety precautions for this experiment can be that the current produced in the coil should not be too high so that it heats up too much. So the possibility for burn can prove to be a difficult thing. Or we to do this experiment, essentially we have to keep this coil energized, or we have to have this coil fed with current for a significant amount of time, at least let's say 1 minute or so, for taking one reading, one full reading, to take the height measurement around the whole thing. So this coil should have to deal with a significant amount of current for a significant duration of time. So having a bigger number of turns of the coil can actually help, so that we can operate the experiment with a smaller value of the current, so the heating effect will be less. So prefer to have a smaller current and larger number of turns, so to avoid heating effect of the coil giving us wrong data. And also in between multiple readings, we should wait for a couple of minutes so that the coil can cool down and eventually give us the more appropriate reading. This is just some additional detail of safety precaution. I think the heating effect is a good safety precaution. And what other stuffs can we talk about here? I think that's basically it. And then you have to show the conversion of this thing into a logarithmic conversion, because there is a power over here. So this would be ln h equals to ln k plus if ln. I mean, you just have to convert this into the logarithmic equation. Then you have to mention the necessary variables. What Raya just proposed, that can we like keep a screen behind the setup and mark the position of the aluminum ring to reduce error? We actually can. This is actually one of the logically acceptable measurement method, is that we can keep a very strong light source in front of the setup and set up a set up a screen behind over here, and we're gonna shine light from the front, and the shadow of the whole setup will be placing on the back, and then we should take measurement from the shadow, so that we will not be physically touching this metal ring to disturb the equilibrium, but we will still be getting the reading. So this is actually one of the yes. What Raya is proposing is pretty much makes sense. I'll tell this again. Let's say you have this setup. You set up a strong light source in front of the setup. So what you are looking at in this place location, and place a screen right behind this setup. And whenever this thing will be levitating, you will have this whole shadow of this whole setup placed behind you on the screen, behind the setup. Now, and then you will take the measurement of the H from that shadow figure, so that you will not be disturbing the equilibrium of the metal ring while it is actually levitating. So that's actually a pretty convincing thing that we can go for. Yes, sure, why not? That can be one thing. Or another thing that we can do is that we can place a meter rule behind this ring, and place a video camera, or take multiple pictures with a camera in the same horizontal level of the ring, and then we can measure the exact reading for the lower level of the ring for multiple places. So that's something that you can also do. You can see in this way, it's also shown in this figure very well as well, is that it shows that this ring is not essentially horizontal. You can see that it's a bit tilted, because we have seen that in the experiment as well. This ring is not gonna be perfectly horizontal. So to get a proper reading, we should preferably measure in all sides, or yeah. I think I made sense. Yeah, বুঝা গেছে? ওকে। এই ইকুয়েশনের ম্যানিপুলেশন তো বলবান তোমরা পারবা, এটা তোমরা জানো বা জানার কথা, এটা কি দেখাতে হবে? If anyone of you need this, I'm going to show this, but if you don't, we'll just skip that part. Okay. না, এখন কিছু খাবো না। তুমি একটু এগুলো পাঞ্চ করা শুরু করো, আমার এগুলো নিয়ে টেনশন লাগছে। আচ্ছা, ঠিক আছে ভাই। So that's the equation. So this will be my y-axis variable. This is my n. This whole thing is my x. This whole thing is my c. So we're going to plot a graph of ln h versus ln f. This should give us a straight line that does not pass through the origin, and that should prove the the way you're going to write is that we'll plot a graph of ln h versus ln f, and this should if the obtained graph is a straight line that does not pass through the origin, then the relationship is valid. From the graph, y-intercept equals to ln k. Therefore, k equals to e to the power y-intercept. এটা হচ্ছে k এর ইকুয়েশন, and then এই গ্রাফের gradient হচ্ছে আর হচ্ছে from and also from the graph gradient equals to n. So এই দুটো ভ্যারিয়েবল বের করতে বলছে আমাদেরকে, সো আমরা এই দুটো ভ্যারিয়েবল কেন বের করতে এটুকু বলে দিই। বুঝা গেছে?
Sir, how are we varying the AC supply frequency?
By changing the knob on the device, on the signal generator. Let me show you a figure for the signal generator to give you a better idea. Good point. Let me show you that how does the signal generator looks like. Okay, yes, so this is signal generator. Okay. So these are the different type of stuffs that you can do over here. We have multiple different type of waves that we can produce. We can produce sine waves, we can produce other type of weird stuffs, and we have a lot of knobs over here. You can change the output voltage of this thing. This is the output. These are the two output ports. I'm not sure how they work because I personally have never handled a signal generator, but what I know that they can be used to produce this thing. Actually, we can look up a video maybe to get a better understanding for this thing. This thing has a lot of channels to operate, to feed into multiple different things. Signal generator producing variable frequency AC videos. How to make a signal generator launch is function in the variable frequency AC generator. So can we see that? Okay, let's pause. So when we're using the recording, while the recording was not here, we actually do the whole figure over here and did some explanation. This is the signal generator coming from the coil. This is a switch. The CR is optional. We can connect it over here. The ring is over here. We have a stand which is kept vertical with the help of a set square and stands and clamps, and we can add two small set squares to have measurement of the two of the ring positions, and that should work. Let's have a look at the mark scheme and then go on with the lights. Have a look. P if is the dependent variable variable. No. Sorry. F is the independent variable, H is the dependent variable, keep current in the coil constant. I did not say that. So you have to keep the current in the coil constant. This question does not say anything about the current in the current of the coil, but you see it pops up because we are working with automatic induction. So if you don't keep the current in the coil constant, you are not going to have the same results. So if we have to keep the current in the coil constant, essentially we're going to require two more equipments. Someone tell me the name of these two equipments. Someone. To keep the current constant, what do you need?
Variable resistor.
Beautiful. And what else do you need?
Ammeter.
You have to see the current is constant. Exactly, ammeter. Beautiful. Thank you. So this should be also in the figure. So disregard the last version. we might as well keep on changing this thing as we go ahead. Method data collection, label diagram of apparatus including working circuit, supply, coil, stand and ring, signal generator, variable frequency power generator. Wow, it's a mouthful, yeah, but you can go for it. Measure the H with the ruler calipers, measure F using oscilloscope or read of the signal generator. So you can see over here, they can mention about the oscilloscope. Oscilloscope is also optional, or you can directly take a read off from the signal generator. Either of these works. Measure H from the opposite side of the range and determine the mean of the weight of the stabilizer. Yes, so we talked about this. This is pretty important. Method of analysis, blah, 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 blah. Safety consideration, reason method to prevent the coil from overheating, switch off when it's not in use, or reason method to prevent injury from hot coil, or do not touch hot coil, use gloves, do not allow small currents. So what so I did not essentially say about the injury part because I was burned from the injury part mentioning from the last question. So I mean, not physically burned, I mean like idea was burned. So that's why I skipped from saying the word burn, but in this case they have given the term burn. I mean they're gonna give you a mark for the burn injury prevention. But I actually mentioned that we're gonna keep the current low and number of the turns in the coil high so that we get a strong enough electromagnetic induction, yet less heating in the coil. And I also did mention that to keep the coil off for in between readings. So I'm gonna get the safety precaution mark. I believe I'm gonna get the mark anyway. Additional detail, 4 marks. 11 points might include use of iron or steel liter stand. Okay, yeah, they have come to this point that it doesn't have to be only metal. It has to be an iron stuff. Method to keep the current constant. So that's where the rheostat and the current ammeter comes in. Method to determine the period from the oscilloscope using the time base. So you know this thing. When using an oscilloscope, F equals to 1/t, mentioning this thing scores you 1 additional mark. So actually mentioning the oscilloscope might actually be a handy thing because you can make sure you get 1 additional mark from here. এখানে একটা জিনিস খেয়াল করো, এখানে জিনিস বলছি না মেথড টু ডিটারমাইন দ্য পিরিয়ড ফ্রম অসিলোস্কোপ ইউজিং দ্য টাইম বেস। ইউ ক্যানট রাইট দিস লাইক মেথড টু ডিটারমাইন দিস থিং, ইউ হ্যাভ টু মেনশন দ্য হোয়াট দ্য মেথড ইজ। The method to measure the time base or the time base looks like this. You have to write this thing: time period equals to length of one period into time base. That's the equation. Length of one time period means what? Whenever you're using an oscilloscope, you're gonna get sine curves like this. To measure the time period, you have to measure how much is the physical length of this whole thing and multiply this length with the time base. This product is gonna give you a total value of something in millisecond or microsecond or second, whatever that your time base is in. And then reversing this thing, frequency equals to 1 upon time period, or you can write time period capital T over here. If you give a symbol over here, then you don't have to write this in word, you can just use the symbol. Equals to 1/t measures the time period. So you have to mention this equation. Method, what method? You have to say that method. You cannot simply write method. So you have to say what it is. Then it says use of coil of many turns or large current to have measurable heights. You see, now they're saying coil of many turns and they're also saying large current. So I'd say for small current and many turns is better. Less heating, more stronger magnetic field, maybe. Logarithmic equation example, log h equals to, so conversion, this conversion shown in your figure, in your writing scores you 1 additional mark. This is value if straight line is produced. They have only mentioned the straight line is produced, but I do highly recommend that you mention that this straight line should be, this is a straight line that doesn't pass through the origin. Did they mention this over here? No, they did not. But you should mention this, that the relationship is valid if we obtain a straight line that does not pass through the origin. That's important. I'll leave the examiner's report study part on your hands. If you find something that is fishy or interesting, discussable, wants our attention, please ask me so. I really don't want to read it through, but I do recommend that you read it through. Yes, Asadul Amin, bolo.
Sir, not related to this. আপনার কালকে যদি ধরেন একটু আর্লি আসি 12টার দিকে, তখন কি পাবো বুকলেটটা?
তুমি আসার আগে আমাকে কল করে আসো। ওই যে লাস্টে 325 একটা নাম্বার আছে না?
জি স্যার।
ওই একটা নাম্বারটাতে কল করে আসো। If it should be ready by tonight. If it is not, you just make a call and make sure.
আচ্ছা ঠিক আছে, মানে কল করে আসবো।
I appreciate that.
Okay, sir.
Sure. Let's pick up the next question. Some of us actually proposed another question. Ashfia gave us a question. ON 2016, question number 252. ON 2016, let's go for that. Do you guys really want me to read this whole thing? I can read this whole thing. Or should I give you some time to read this whole thing? 5 minutes?
Give me a few minutes to read this.
Okay, I'm give you everyone 5 minutes to read this whole thing. এটা বাই করো তোমাদের মার্কস স্কিম এটা কোথায় আছে বাই করো এটা হচ্ছে কোন ইয়ার এটা হচ্ছে ON 1351 কোশ্চেন নাম্বার 1 এটা বাই করে এটা পড়ো আর যাদের কাছে নাই নেট থেকে ডাউনলোড করো ডাউনলোড করে পড়ো আর কথা হচ্ছে এক্সামিনেশন রিপোর্ট আমরা কোথায় পাবো স্যার এক্সামিনেশন রিপোর্ট ডাউনলোড করতে পারা যায় এনিওয়ে you should have it in your hands. I'll give you 5 minutes. Read it through. If you have any question, keep them in your head so that you can ask me all the questions at a single time. But finish reading first. Ashi Shubhu class করতেছে না? Haven't had a single question from him. আমি চ্যানেল টু the link দিই নাই দিছি তো hey এই যে হ্যাঁ দিছি তো Shubhu also asked a question but he is not here acha maybe he is starting up okay no problem I'm pausing the record. Okay, we're using the recording. So, any of you have any question about this examiners report? That anything seems fishy or deserves our attention? Asadul Amin?
One of the lines says like the ring. Some candidates were worried the ring would fly off.
Yep.
Is that an actual thing you could write?
Yeah, that's why I said that we should find out the maximum range first and then go for reducing the frequency slowly to get more readings. That's a dependable way to go for this. But rings flying off can be a problem if we place the ring first and then switch it off later. So we can avoid the ring flying off, as you have seen in the video, is that we can switch on the coil first, then slowly place the ring into the rod then. So the sequence that matters. So switch off the current first, then place the ring. That would not cause it to fly off. But if you do the other way around, then the ring can very well fly off. Make sense?
Yes, sir.
Beautiful. Yeah, Asadul Amin, you have your hand raised. Anything? Yes.
No, sir, I forgot to raise my hand. Lower my hand.
No, sorry. Okay. Anyone else? Did anyone else find anything that is exclusive? No. Okay, let's go for the next question. So here we have another question from Ashfia. That is October number 2016, question number 2. Let's have a look. October number 2016. W16. $52. And let's close other stuff. Also open the masking and examination report. So this is question number 2. So might as well be some mathematical calculation involved. Let's have a look. So this question says, a student is investigating the characteristics of a light emitting diode LEDs. Each LED needs a minimum potential difference across it to emit light. Yes, that's called the barrier potential. For any diode, that's a very important thing, barrier potential. The circuit is set up as shown in figure 2.1, battery, variable resistor, potential. So this is basically a potential divider. We have the voltage, diode, LED, and the limiting current factor. This thing. Okay. The potentiometer is adjusted until the LED just emits light. So the potential difference V across the LED is measured. The experiment is repeated for LEDs that emit light of different wavelength lambda. This says that the V and lambda are related by the equation V equals to P lambda to the power Q. The finger graph is plotted on log V on the axis, on log lambda on the axis, given expressions of the gradient and y-intercept. Okay, this is doable. Then comes this with the lambdas in this equation. Okay, Ashia bolo difficulty কোথায়? এই টেবিলে কোন difficulty?
No sir, আমার টেবিলও difficulty নেই, লাস্টের একটা কোয়েশ্চেন আছে নাম্বার ই ওটাতে।
এটাতে?
জি স্যার।
আচ্ছা,
So the
এটা
quirk of
এখন
this question is that the error bars are horizontal.
okay, okay, beautiful, yeah. আচ্ছা, so এখন আমি আচ্ছা ঠিক আছে, let's have a look at these stuffs. I have a bit of an idea what happens over here. Let's have a look at this one and we might as well consider this question. E number was a similar experiment is carried out with a diode emitting infrared radiation of wavelength 950 nanometer. Determine the minimum potential difference V needed to emit this radiation. So 950 নানোমিটারের জন্য আমাদের পটেনশিয়াল V কত হবে? এখন এখানে একটা জিনিস দেখো, আমাদের অলরেডি এই ইকুয়েশনটা আছে। কোন ইকুয়েশন? এই যে এই ইকুয়েশনটা অলরেডি আছে। সো V equals to P lambda to the power Q. আমরা আমাদের ম্যাথমেটিক্স থেকে কিসের থেকে মানে ক্যালকুলেশন থেকে আমরা P এর ভ্যালু বের করছি, Q এর ভ্যালু বের করছি। এই দুটো ভ্যালু বের করা হয়ে গেছে না? আচ্ছা, সো তার মানে হচ্ছে এই ইকুয়েশনে আমাদের এই কনস্ট্যান্ট দুটোর ভ্যালু জানি, আমাদের ইনফ্রারেডের জন্য একটা স্পেসিফিক ল্যামডা ভ্যালু দিয়ে দিয়েছে, দ্যাট ওয়াজ অলসো গিভেন ইন what nanometer, I think this lambda is given in 950 nanometer.
950
সো আমরা ডিরেক্টলি ওই ভ্যালুটা ইউজ করতে হবে, কারণ এখানকার সবগুলো ভ্যালু ন্যানোমিটারে দেওয়া ছিল। সো we're going to place directly 950 over here and use the values of P and Q's as we have found in our through our calculation, and that should give us the value of V automatically. That's what I think should work.
বাট স্যার এখানে তো মানে মিনিমাম পটেনশিয়াল ডিফারেন্স স্যার, তো ওইটা কিভাবে বুঝবো?
মিনিমাম বলছে? হ্যাঁ, আচ্ছা,
হ্যাঁ
মিনিমাম পটেনশিয়াল ডিফারেন্স যদি বের করতে বলে তার মানে হচ্ছে এই ভ্যালুর জন্য আমাদের P এর try to think of try to look at this equation, try to understand, it should make sense. V is the product of P and lambda to the power Q, ঠিক আছে? So if you want to get a smallest value of V by these things, all of these three terms has to be as small as possible, because the smallest of all of these values individually will give you the smallest value of V. Now lambda in this case is not going to be a variable because the lambda value is already given to us, which is the infrared radiation of 950 nanometers. That's a constant. But in your calculation, did you find P with its uncertainties through this calculation? The value of P, was it found with the uncertainties over here? এখানে কি P এর ভ্যালুগুলো আনসার্টেনিটি সহ আসছিল না, ছাড়া গুগল করতে হয়েছে? একটা মার্কিং দেখে 1 মিনিট মার্কিং দেখে বুঝা যাবে। এখানে আমাদের ভ্যালু আসছে হচ্ছে Q is gradient and in the range of -2.50 to -2.7 given to 2 or 3 sir. Use of power P equals to 10 to the -3. আচ্ছা, সেখানে আমাদের কোনো আনসার্টেনিটি আসে নাই। আচ্ছা, এখানে কোশ্চেনে বলছে হচ্ছে দাঁড়াও, oops no yes, oh Ashfia, you don't have to bother about this. I'll tell you why. Read this thing. The potentiometer is adjusted under the LED just emits light. The potential difference V across the LED is measured. The experiment is repeated for LEDs that emit light of different wavelength lambda. এখানে আমরা যে ভিটা মেজার করতেছিলাম এক্সপেরিমেন্ট থেকে, that V itself was the minimum potential, তাই না?
Oh has
By characteristic of the experiment we are measuring the minimum potential. So if you calculate some values out of this constant, you're also going to get the minimum potential. So in this case আমাদের uncertainty value আসবে না. So it's just a part of the statement or the sentence construction that needs to be within the question.
কিন্তু স্যার যদি মানে কোয়েশ্চেনে না লেখা থাকতো যে মিনিমাম পটেনশিয়াল ডিফারেন্স তাহলে আমাদের পি আর কিউ ইচ মিনিমাম বের করে নিতে হতো
I would not দাঁড়া বলতেছি দাঁড়া এক মিনিট আমি একটু চিন্তা করে বলি Thank you. ওখানে ওই নোটও পেন দিছি তুমি এগুলো নিয়ে পাঞ্চ করতে শুরু করো আমি ক্লাস শেষ করে আসি তোমার সাথে যোগাযোগ করতেছি এগুলো নিয়ে যাও 5% নিয়ে যাও সরি the thing is for this experiment we actually as the experiment tells us that whenever we'll do this experiment we are going to have the LEDs light up for a very minimum potential and anything above for that potential the LED will glow just fine. So we're trying to measure the minimum potential. That's a very important factor to consider. Now, the way it is really important that if we want to find, if this experiment was done for a basic value, where the experiment design was not done for minimum potential, let's say for any other experiment that you are measuring some potential V, where you are not limited by the term minimum, you are trying to measure some potential V for a certain experiment. ওই ধরনের মানে তোমার অরিজিনাল অ্যাপারেটাস সেটআপের মধ্যে মিনিমাম টার্মটা ইনভলভ না ওই লজিকটা ইনকর্পোরেটেড না if that was the scenario in that case if you are trying to find out the minimum value for some constant in that case you would require the lower threshold of all the constants involved সেই কেসে আমাদের হচ্ছে p এর জায়গাতে ইউজ করতে হতে হচ্ছে p minus delta p ওইদিকে q এর জায়গাতে ইউজ করতে হতে হচ্ছে q minus delta q but that would require the original experiment not to be limited by that idea of minimum potential. বুঝতে পারছি?
Not to be limited by the idea of potential ওটা বুঝিনি
বলতেছি মনে করো তুমি ধরো এই ফর এক্সাম্পল দিস এক্সপেরিমেন্ট মনে করো আমরা অন্য কোনো একটা এক্সপেরিমেন্ট করতেছি in that experiment we are measuring some voltage by some apparatus setup and everything and that experiment description does not ask us to find out any minimum or maximum potential. It just tells us that the voltage measured is this. So within the description of the whole apparatus set about the working of the experiment, the term minimum is not involved. এইটুকু আগে বুঝো let's say এটা বুঝছো
এখানে ওখানে ওই কোয়েশ্চেনে স্পেসিফিক কোয়েশ্চেনটা মিনিমাম ওয়ার্ডটা মেনশন করা থাকবে
হ্যাঁ এখানে অলরেডি আমাদের মিনিমাম পটেনশিয়াল ডিফারেন্স মেনশন করা আছে so which means that we are working with the minimum potential difference that's why ultimately that answer that we get was also for minimum potential difference but if this thing was not present we were only measuring some voltage for some very specific experiment and then based upon those experiment if you are asked to find out the minimum possible value in that case you would have to use the lower limit values and you'd have to calculate the
p minus delta p or q minus delta q in that case
precisely বুঝছো
জি স্যার
beautiful রায় একটা কোশ্চেন লিখছে unrelated but যখন আমরা ভোল্টমিটার মেনশন করব in our answer do we have to mention its resolution in most cases no for question number 1 whenever you talk about the equipments you just mention using the equipment and the process for how to use the equipment we assume that the equipments that we're using are precise enough for that purpose precise enough for that purpose means there are certain scenarios where the precision of the equipment has to be come from your understanding for example for different type of length measurement in some cases the meter rules are relevant in some cases vernier calipers are relevant in some cases the micrometer screws are relevant there are applicable cases for those things similarly if you think for time measurements in some cases light gates are relevant in some cases high speed cameras are relevant for heating experiment maybe the wall clock is also relevant you don't even need a stopwatch so certain variables which you know by experience that they have a certain resolution of working that is mandatory or convenient to use for their aspect you can mention those but for other devices like CRO or signal generator or millimeters or voltmeters, ammeter or digital multimeters, you don't have to mention their resolution things, because we assume that we're operating those things in their functional appropriate resolution value. Beautiful. Anything else, Palaban?
Sir, my question pertains to a specific one of May June 1351. It's just the fact of how do we measure flow rate of water.
I'll have a look. কোনটা বলছো, মে জুন?
May June 1351.
মে জুন 11?
13, sir. May June 1351.
That part was getting cut off. May June 1351. This one. Okay.
Particularly, how do we measure flow rate, sir?
Measuring flow rate, well, you don't need a fancy device to measure flow rate. Measuring flow rate can be done in a pretty crude way. The most crude way, I'm using that term, crude way to measure flow rate is that you have to measure this flow rate in what? Kg per second or volume per second, meter per second? Flow rate Q. They haven't mentioned this.
I suggested, sir, like a known volume.
Yeah, they say they mentioned volume per unit time. So meter cube per second. Okay. So, or meter cube per minute, maybe. Meter cube per second would be convenient to use for SI unit. Acha. The idea is that you place a large enough bucket in front of this channel. Then, as you allow the water to flow through the horizontal narrow tube, and you start the stopwatch and allow the bucket to fill up for the duration of the time. And the moment you stop your observation, you stop the stopwatch and remove that bucket immediately. So you would have the time measurement in your stopwatch, and you have collected certain amount of water in your bucket. I'm talking about bucket because maintaining a measuring cylinder immediately at the bottom of the flow rate channel narrow tube might not be a good idea. So you collect the whole water in a bucket, and then you take your time to measure that amount of volume of that water using beakers or measuring cylinder, however appropriate. This would essentially cause some water measurement to be a bit smaller than what it actually is, because every single time you're going to use the bucket and then you're going to use it in the measurement cylinder, some water will be left in the bucket. So repeat and average might be a good idea.
Thank you, sir. I got it.
Beautiful. Okay, Raya gave us another problem. 970-51 ON14. W14. 51, question 1. So we have a wind flow, we have a turbine, we have a lamp. Participation in the lamp depends on the angle between the axis of the turbine and the direction of the wind, as shown in the top of figure 1.2. Sure, why not? They suggested that P equals to K cos theta. Okay, is a constant. Okay. Question will say that power Q measure করব. What Abia says should work. I mean, the old voltmeter ammeter combo can work. I mean, you can connect an ammeter in the series and a voltmeter in parallel with the lamp and take a stable reading for those and do the product to get the value. Because we are working with DC over here, so it shouldn't be much of a problem. So we don't have to bother about the RMS or the non-RMS value. That can work, P equals to VI. This is one of the ways, or there is a certain device that's called Joule Meter, which can measure the amount of energy that passes through an electrical device, which is helpful to measure the actual power consumption of a device. I'm not sure if they actually. Let me show you what I mean. Let me show you what I mean. these gaps seem very small. They used to be, আমি কি এখানে zoom in zoom out করছি? No. Electric power meter. No. Digital. So there you see. So this is the thing that I was talking about. There are certain electronic devices which actually has built-in ammeters and voltmeters, obviously, and so you have a certain voltage they measure by the voltmeter. You have a certain current. For this, currently there is no current in this display, that's why the power is 0. But any single time, if there is no zero error, then the product of these two variables should be equal to this one. So if you have this device available to you, then you might as well get the power directly out of the display. But I'm not sure whether mentioning this equipment would be a good idea, because availability of this equipment in a laboratory might be questionable. So going for the voltmeter ammeter combo is, I think, makes better sense. বুঝছো? Okay. Okay, I have one question from Samiha in the messenger. May June May June 1852 question number 1. Okay, May June 1852 question number 1. May June 18. S18. রান্না করতেছে, সুগন্ধ আসতেছে। Nice question, nice question. A student is investigating the diffusion of light of a compact disc. As shown in figure 1.1, the student observes the skin on a pattern of maximum minimum, which is similar to the produced by diffusion getting. The distance h is measured to one of the maximum. It is suggested that the relationship between h and a wavelength lambda of the incident light is equal to n lambda by d plus b, where it is out of the maximum and d and b are constant. General Lambert experiment the relationship between h and lambda explain however this could be used to determine t and b. Blah blah blah. আচ্ছা, বলতেছি, first of all, what you need to understand that how does a CD do this? What property of a CD causes it to produce that alternative pattern? So let me show you that reasoning first, so that you can explain this question a bit more understandably. That's an applicable word here, I'm not sure. Okay. Beautiful. We got what I need. This is practically how a CD stores data. This is the label. This red thing is the sticker. This blue thing is an acrylic thing. And there is a certain aluminum layer that is lapped on that CD that looks like this. They have a certain gap size, and the thickness variation is 125 nanometer. This is very important. The thickness variation is 125 nanometer. Now what happens, because of this gap, whenever we send and this is polycarbonate plus, this is basically the structural material of this thing. যখন কোনোটা সিরিতে স্ক্র্যাচ পড়ে, এই সারফেসটাতে স্ক্র্যাচ পড়ে, স্ক্র্যাচ পড়লে তখন ভেজাল হয়। আচ্ছা, the thing is, এটা হচ্ছে একটা ভিউ, আরেকটা ইমেজ দেখাই। Beautiful. Let's say this one. Here you can see multiple layers of CD. This is actually this part, which means this is a radial inscription of the data. So you have long gaps, you have short gaps, long gaps, short gaps. Each of these gap 0.83 micrometer. You can see it's written over here. Is it visible? এখন তো আমাকে বলবে কুকিজ অ্যাকসেপ্ট করতে বলবে আমাদের, বল নাই? আচ্ছা, আই অ্যাজিউম যখন এখানে কুকি অ্যাকসেপ্ট করতে বলবে। সো এখানে দেখো 0.83 মাইক্রোমিটার মিনিমাম একটা জিনিস দেওয়া আছে। এইটুকু হচ্ছে আমাদের সিডির রিড অফ রেজলিউশনের সাইজ। এইটুকু একটা সার্টেন বিট রিপ্রেজেন্ট করে। সো মেবি দ্য ডেপথ রিপ্রেজেন্টস 1 and the flat represents 0. So if you have double the length, you have 1 1. You have double the gap, you have 0 0. You have triple the gap, you have 1 1 1. So you have a series of ones and zeros which are later converted into data. So এই যে গ্যাপগুলি আছে, এই গ্যাপগুলি জিনিসটা হয় whenever we actually shine a certain monochromatic light onto this thing, each of these individual gaps, which is shown over here, the light that reflects off this boundary and that light that reflects off the offset deeper boundary, these two lights become out of phase because of the reflection. Because one has to cover a shorter path if they are falling onto the screen, the other one has to cover a bit longer path. And how much longer path it has to cover is precisely related to this depth over here. And it is made, and series are made with very precision technology, where this uniform thickness part is maintained all through, and I mean all through. That's essentially what makes the diffraction pattern or the whole maxima and minima pattern, because of this same phases reflecting and then non-similar phases reflecting. এই রিজনিংটা আগে বুঝছো কিনা সামিহা? সামিহা লেফট। ও না আছে, আচ্ছা। সো এটা হচ্ছে একটা পার্ট। সো
ওয়েথের উপর কি ডিপেন্ড করে এই পাথ ডিফারেন্সটা?
হ্যাঁ, এক্স্যাক্টলি কোন কালারের লাইট দিয়ে এই সিডিটা রিড করা হবে, দ্যাট actually matters because the depth, I mean typical series means regular series which are 750 megabyte. They are typically read with a red laser, which means they have a pretty large wavelength, so this thickness can be pretty large, which is easier to manufacture because your machinery doesn't have to be that precise. Blu-ray discs are more dense because their wavelengths are smaller, so Blu-ray discs can read for even thinner, smaller size of data, which means in Blu-ray disc you're going to have this kind of very compacted data, so your individual resolution size becomes smaller. So CD তে দেখো এত বড় বড়, DVD তে হচ্ছে এত বড়, Blu-ray disc হচ্ছে মানে এত বড় না, আরো ছোট পিক্সেল সাইজ, তোমার Blu-ray disc হচ্ছে আরো ছোট। বুঝছো কি বলছি? So if you want to read off even a smaller resolution size of the CD or the DVD or the Blu-ray disc, your light wavelength has to be smaller as well, which means you have to slowly shift towards the violet range or even ultraviolet range, those kind of regions. Rafid, বুঝছো কি বলছি?
জি স্যার।
Beautiful. So that's that. This same thing is also possible to achieve on a thin film of oil that is spreading across some water. That can also give us that kind of pattern. For those of you who have seen this thing in actual life, you know what I'm talking about. For those of you who haven't seen what I'm talking about, let me show you an example. This is what I'm talking about. Patch of oil giving you rainbow colors because of this surface giving you one reflection, the underneath surface giving you another reflection. These two merging onto each other, giving you the sensation of different color. Awesome, no? Anyway, I find it
Pretty
awesome.
cool.
Yeah, I find it really good to be able to explain stuffs in a logically what can I say, logically complemented ways. আচ্ছা, ফার্দার জিনিসটা বলতেছি, let's get back to the question. এখানে বলছে হচ্ছে A student observes on the screen of a pattern of maxima and minima which is similar to that produced by diffraction grating. The distance h is measured to one of the maxima. The distance h is measured to one of the maxima. So এখান থেকে এইটুকু পর্যন্ত হচ্ছে একটা maxima point. এটা হচ্ছে আচ্ছা, ফার্স্ট অফ অল এই এক্সপেরিমেন্ট ওয়ার্ক করার জন্য এসেনশিয়ালি আমাদের এই লাইটটা মনোক্রোমাটিক লাইট হতে হবে। আদারওয়াইজ আমরা যদি এখানে হোয়াইট লাইট সেন্ড করি, if we send white light over here, we're going to get a rainbow pattern. Detecting individual maximas and minimas would be impossible. Not impossible, it will be difficult. Let's put it that it's going to be difficult. So when we will do this, go ahead and explain this experiment. It's important that you mention that it is done by a monochromatic light. That's important. Which is going to give you bright dark alternation. Easier to measure the maximas and minimas position. It is such that the relationship between h and wavelength lambda of the incident light. So you see wavelength lambda. So you have to do the experiment with the monochromatic light, obviously, where n is the order of the maxima and d and d are constants. Design a laboratory experiment to test the relationship between h and lambda. So h and lambda মধ্যে আমাদের relationship বের করতে হবে. So try to think about it. What are we trying to measure? We will have to have the same n. We'll have to have the same d, and we'll have to have the same b. D and b are default constants, which we don't have to bother. But preferably this series should not be shifted from this position, and this angle of light from which we are sending, this shouldn't be varied. These are just additional detail. So angle of light hitting the series surface should be kept constant. The distance from the series to the screen should be also kept constant. And then we're going to change the color of the light source. So different colors, and we should have a logical way to measure that wavelength, because you can see over here that we are trying to test the relationship between h and lambda. So if you want to measure the test relation between h and lambda, you have to be able to plot h and lambda. So lambda has to be measured. So how would you measure the wavelength of light? To measure the wavelength of light in any applicable experiments, the two possible ways that the paper 5 prescribe is that we're going to have this light source. So let's say now we're going to do our experiment with red light, and we're going to have 7 different colors or maybe 8 different colors of light we have prepared with just basic transparent foil plastic cover on the sources, white sources. But we first have to perform either a double slit experiment with that light source, or an actual diffraction grating experiment using that light source to know reliably the wavelength of that light source. So you don't have to go ahead deep into the description that we're going to perform the double slit experiment like this and that, or we have to perform this the diffraction grating in this mechanism. You don't have to go into whole detailed description for this, but whatever mechanism that you mention, one of those, don't mention both of them. Both of them are not required. You have to mention the working formula for this, preferably. So if you go for double slit experiment, you just write that we use the light source and perform a double slit experiment using the light source, and using the formula lambda equals to ax by d, we calculate the lambda of that light source. Then we use that light source for our experiment, and this has to be repeated for all the individual light sources that you're going to use for this experiment to work, because you have to know a numerical value for the wavelength of that light source for it to work. এই পার্টটুকু বুঝা গেছে কিনা? Confirm this part first, then I'm going to go further. যে ল্যামডাটা আগে মেজার করতে হবে, ফার্দার একটা এক্সপেরিমেন্ট থেকে এটা মেজার করে আনতে হবে আগে। এটা বুঝা গেছে কিনা?
Sir, what about a pre-calibrated filter?
Difficult to achieve or made available in laboratory.
Okay, sir.
সামিয়া, এই পার্টটুকু বুঝছো?
স্যার ল্যামডাটা কিভাবে পাবো, এটাকে এক্সপ্লেইন করব না?
না, তুমি জাস্ট যে কোনো একটা মেথড মেনশন করবা। If you mention the double slit experiment, you write that formula, lambda equals to x by d. If you mention the diffraction grating, you write d equals to d sin theta equals to n lambda. দুটো জাস্ট ফর্মুলাটা মেনশন করলে হবে। ফর্মুলাটা মেনশনটা অনেক সময় লাগে না। We're going to look at the mark scheme after a while. We're going to see what the examiners are looking up from us. But you have to mention at least one of these ways, and you just say that using this experiment with appropriate calculation, we're going to measure the lambda of that light source. Then you're going to directly jump into the details of this experiment.
জি স্যার বুঝছি।
Okay, that's to begin with. এরপর হচ্ছে আমরা এখানে যেটা করব সেটা হচ্ছে we're gonna have an observation of the on the screen and we're gonna count from the very bottom, and we're gonna count from here and go up, and we're gonna choose a certain number. Let's say if it's 2, then it should be the, if it's the second maxima that we're choosing, then we're gonna be taking reading for the second maxima also. If it's the third one, we're gonna choose the third one also. N is not gonna be a variable, important information. N is gonna be constant, so which means that you're gonna change the change the light source over here, which is going to bring about some change in height of the same numbered constitutive fringe pattern, constitutive maximum, and you're going to measure these two variables. So these are your change variables. These are the things which are going to be undergoing change. So এই জিনিসটা করা লাগবে, and then we're going to observe this pattern, and we're going to count the exact same number of pattern as we have decided earlier, and measure that height. Measuring the height can be precisely measured by a meter rule, or we can do one thing is that while we're seeing this whole thing, I mean, placing the meter rule in front of the screen actually can vary the distance from the CD to this screen, because your meter will be able to have some thicknesses. So one good idea is that we can actually print out a meter rule with 100% scale and paste it on the screen, like gum de lagai dibo, and take measurement out of it so that its thickness is very small. Or we can actually give a mark on the screen and at the appropriate location of the maximum location, and then later use a meter rule beside that mark to measure the actual thickness. So to measure the actual height. So what I'm trying to propose here is that the thickness of a meter rule should not cause decrease of the height or change of the height. That's something that you should be careful to avoid. And obviously repeat and average goes without saying that we should do the whole measurement multiple times and take the average of those values. And then among the things, the experiment should be done in an otherwise darkened room so that we can see a good pattern. The screen should be made sure to be perfectly vertical with the table surface.
এখানে এনটা কিভাবে কনস্ট্যান্ট রাখবো?
N is a choice that you have to make. For example, বলতেছি মনে করো let's say আমরা এখানে একটা সার্টেন কালারের লাইট দিলাম, এখানে আমাদের একটা প্যাটার্ন আসলো, তো আমি দেখলাম যে এখানে আমার প্যাটার্ন তো আস্তে আস্তে উপর দিকে যেতে থাকবে। So let's say I choose for the first set of reading, I can choose that I'm going to do this experiment for the n equals to 3 value. So আমি এখান থেকে দেখা শুরু করবো যে let's say the first bright spot n equals to 1, second bright spot n equals to 2, third bright spot n equals to 3. You can count from one side, so that you can always count for the same n value. বুঝছো?
স্যার বুঝলাম না, একটু আরেকবার বলা যাবে?
মানে হচ্ছে তুমি যখন এখানে ফ্রিঞ্জ প্যাটার্নটা প্রডিউস করবা, in this fringe এই দেখো, the student also says pattern on the scheme of maximum minimum, which is similar to that produced by a differential grating. The way it usually works out is that whenever we do this experiment, এই বরাবর একদম horizontal level, typically we get one maxima. If you start observing from the very bottom of the screen and you slowly start to observe upwards, you're going to see alternation of bright and dark spots. So let's say you detect the first one. So first maxima, then first minima, second maxima, second minima, second maxima, third minima. The pattern will continue upwards. You have to choose a very specific number of maxima value that you would prefer to do your experiment for the entirety of the upcoming values, upcoming readings. So if you choose that I'm going to take measurements for the second maxima. So let's say for your first reading, whenever you set your first light source, you find out the second maxima and measure that height. You record this. Then you apply a different color light that produces a different pattern where the second maxima would be at a different height. Once again, you're gonna detect the second maxima and measure that second maxima's height so that the n value is always same. You're not going to choose different maximas. From the pattern, you're going to always measure the height of the same maxima.
জি স্যার বুঝছি।
And experimental precaution কি হতে পারে? Safety কি হতে পারে? What can you think of the safety for this thing? I mean, in terms of human safety or in terms of Equipment safety. What could possibly be a safety for this experiment?
Eye protection, sir. You shouldn't flash the thing in your eye.
স্যার
Wow.
ডায়াগ্রামটা একটু দেখাতে পারবেন?
Diagram. আচ্ছা দেখাচ্ছি, সমস্যা নেই। I cannot think of a safety precaution. I mean, visible light coming reflected off a series surface. Can it be actually harmful for our eyes?
You have to do it in a dark thing, sir, and the light's concentrated. So if it hits your retina, you might face.
Acha, this is actually pretty interesting. No, hold up. To be able for us to be able to do this experiment, we'd preferably have to do wearing eye protection, protective glasses to damage it. That can actually be a good point, but my brain is somehow not buying it completely. So, but I'm gonna cheat and have a look at the solution. So let's look at the mark scheme. আমি তোমার ডায়াগ্রাম দেখাচ্ছি, আগে মার্ক স্কিমটা দেখে নিই, তারপর ডায়াগ্রাম দেখাচ্ছি।
লাইট ইন্টেন্সিটি যদি অনেক বেশি হয় তাহলে এই পয়েন্টটা ভ্যালিড হবে।
এখন লাইট ইন্টেন্সিটি আমি অনেক বেশি দিব কেন? The light source that I'm working with, I should be able to control the intensity of this light source.
Sir, it should be like a focused beam, so to increase the accuracy of the experiment.
Achieving a focus beam is another big problem. Like we have to have those torchlight stuffs which actually can make a beam go centralized. Acha, I get your propositions, but let me have a look at the marks. This is 52. Yeah, 52. That's 50. That's 52. Lambda is a maneuverable, electricity maneuverable, vary lambda and measure H, keep angle of incidence on light or onto CD constant. Okay, they have mentioned about the angle.
এখানে কি আমরা প্রতিবার প্রোটেক্টর দিয়ে মেজার করব অ্যাঙ্গেলটা?
I would not prefer to mention that. কারণ হচ্ছে it's a light beam. If you want to measure that angle precisely, you have to first have a mechanism or have a reference surface on which the light beam should fall upon, using which you should be able to measure that angle. But that can actually prove to be pretty difficult. What I am going to propose to keep this angle of incidence constant is that just a second. Okay. Sorry. So what I'm going to propose is that if this is the CD and we're going to have the light source somewhere over here, this is our light source which is shining light into this direction. I'm going to say that we're going to keep the height of the light source from the table and from the base of the height to the position of the start point of the CD. I'm going to keep these two distances constant for all of my experiments. Maintaining and measuring these two distances constant is far too simpler and easier to achieve compared to measuring the actual angle of the light falling upon. But if I can keep these two angles same, I'm definitely sure by trigonometry that this angle will be constant as well. Do you get my point?
Oh, sir, বুঝছি, হ্যাঁ।
So আমি এই জিনিসটা propose করছি. I'm going to draw the light source over here. So I'm going to draw pretty much
পজিশন চেঞ্জ করি তখন আবার এই অ্যাঙ্গেলটা চেঞ্জ হয়ে যাবে, তখন ওইটা। আচ্ছা স্যার, বুঝছি।
আমরা প্রত্যেকটা এক্সপেরিমেন্ট প্রত্যেকবার রিডিং নেওয়ার আগে আমরা এই হাইট এবং এই ডিসটেন্স এবং as I propose that we should also measure this distance as well, এগুলো সবগুলোই কনস্ট্যান্ট আছে কিনা সেগুলো আমরা মেজার করে দেখব। So in your diagram, you can label those, let's say D1, D2, D3. You can say that before taking every reading, we should measure all of these distances as labeled in the figure D1, D2, D3. They are kept constant. So that can be a very short description covering a lot of features. বুঝে গেছি?
জি স্যার।
এইটা একটা পার্ট হতে পারে। আর এখানে প্যাটার্নটা কিরকম হবে সেটা অ্যাকচুয়ালি লেবেল করার কিছু না। অ্যাকচুয়ালি এখানে লাইট সোর্সটা আঁকা, লাইট সোর্সের সাথে এখানে স্ট্যান্ড ক্ল্যাম্প আঁকা, স্ট্যান্ড ক্ল্যাম্প অ্যাঙ্গেল একটা পড়তেছে। এখানে হাইট মেজার করার জন্য এখানে আমাদের মিটার রুল লাগবে। সো অ্যাকচুয়ালি I'm not very comfortable with drawing the meter rule in front of the screen over here, because drawing the meter rule in front of the screen would essentially propose that I'm going to place the meter rule in front of the screen while the light is shining up on the screen. That is something that I'm not okay with. So I would prefer that I'm going to prefer to draw a set square over here just to make sure that the screen is perpendicular. And how am I going to measure this H? I'm going to write it in description. That I'm going to either
মিটার রুলটা ক্ল্যাম্প করে দেখাতে পারি না পাশে সাইড পেজ ভাবে?
We can draw the meter rule over here, but the thing is, if you want to measure the height of the numbered pre-decided number maxima location, মিটার রুলটাকে তো আমার তাহলে ওই প্যাটার্নের সামনে আনতে হবে। আর যখন এই মিটার রুলটাকে প্যাটার্নের সামনে আনবো, মিটার রুলের যে থিকনেস থাকবে সেই থিকনেসের জন্য আমার হাইটটা কিছু হলে কি করবে? ভ্যারি করবে। So to have precise measurement, you either have to achieve a nearly zero thickness meter rule. For example, steel meter rule গুলো যদি ইউজ করা যায়, ওগুলোর thickness about 1 millimeter, not essentially zero, but should be workable within the range of this experiment. Or the other thing that I propose that we're going to print 100%. We are going to print a meter rule with appropriate with perfect 100% scale, and we're going to paste it onto the screen, and we're going to take reading from that thing. Or other thing that you can do is that এখানে যখন আমাদের পড়বে তখন আমরা এখানে একটা মার্ক দিব, ফিজিক্যালি আমরা একটা কলম বা পেন্সিলের মার্ক দিলাম, পরে মিটার রুল কাছে এনে আমরা ওই মার্কটার হাইট মেজার করলাম, সেটাও হতে পারে। বাট placing the meter rule while the pattern is being created, this is something that I'm not okay with. বুঝছো কেন?
স্যার তাহলে এখানে সেট স্কয়ার কেন দিচ্ছি?
সেট স্কয়ার দিচ্ছি স্ক্রিনটাকে ভার্টিক্যাল রাখার জন্য।
স্যার ওটা তো ইনিশিয়ালি একবার করলেই হবে নাকি?
হ্যাঁ সেট স্কয়ারটা দিতেছি বেসিক্যালি আমার লেবেলিং পয়েন্টস বাড়ানোর জন্য।
জি স্যার, এখানে একটা অ্যাডিশনাল লেভেলের কথা বলছো।
হ্যাঁ এখানে তো আমার সেই স্ট্যান্ড, লাইট সোর্স, সেট স্কয়ার, আর তুমি যদি এখানে ডিসটেন্স গুলো মেজার করতে বলে সেট D1, D2 and D3, এগুলো ছাড়া তো আর কিছু লেবেল করতে পারতেছ না। সো I just prefer to draw the set square to increase my labeling points. That's it.
স্যার ওয়েভলেন্থের জন্য একটা লেবেল দেখাতে বলছো, এটাকে আলাদা করে দেখাতে হবে?
ওয়েভলেন্থের জন্য লেবেলিং দেখাতে বলছে? যেটা মার্সিন দেখি, মার্সিন কই নাই, কই দেখি এক মিনিট। Label diagram of workable experiment including light source, CD and screen, method to support the light source label and at least one other level. Method to support the light source, okay, stand clamp, light source, CD and screen, okay, the same thing that you have, light source labeled and at least one other level. So light source labeled and at least one other level মানে হচ্ছে stand clamp অথবা set square যে কোনো একটা level থাকতে হবে। Method to change the wavelength, use filters or different lasers or LEDs, okay. Method to determine the lambda, example read from filter or label or experiment. Read from filter, আচ্ছা read from filter এই জিনিসটা হচ্ছে যে if you have some actual color filters which are labeled for their precise wavelengths which can be bought, so they have accepted this part which Abi has just proposed, so apparently it is acceptable. Or you can go for this I know for a fact is universally acceptable for all the experiments where lambda is a measurable variable. You can always mention the use of either this experiment or this experiment to get the value of lambda and then use it for the subsequent experiment.
স্যার এখানে লেবেল বলতে কি হচ্ছে যে সেকেন্ড পার্টে আলাদা করে দেখাতে হবে
এই লেবেল?
জি স্যার,
এটা হচ্ছে ফিল্টার স্ল্যাশ লেবেল, মানে হচ্ছে the color filters দেখালে বুঝবা। টিপিক্যালি এটা মনে করো একটা কালার ফিল্টারের 4টা ডিফারেন্ট কালার ফিল্টার। টিপিক্যালি এই কালার ফিল্টার গুলোর গায়ে ওরা অ্যাকচুয়াল ওয়েভলেন্থ লেখা থাকার কথা, যে এখান থেকে তুমি এক পাশ থেকে হোয়াইট লাইট সেন্ড করবা, আর পাশ থেকে রেড লাইট বের হবে, বা আর পাশ থেকে ইয়েলো বা গ্রিন বা ব্লু বের হবে। ওই এক্সাক্ট ফ্রিকোয়েন্সি গুলো ওয়েভলেন্থ গুলো কত হবে সেগুলো এটা গায়ে লেভেল করা থাকে। এই লেভেল বলতে হচ্ছে রিড অফ ভ্যালু বের করছে, বুঝছো?
জি স্যার।
আচ্ছা, measure h to the rule or rebel rule shown in diagram close to the screen with h indicated. So either so they have said that it can be shown in the diagram. I would prefer not to draw it on diagram. It's just my personal preference. Plotted graph of h against lambda, plotted graph of h against n lambda. এগুলো তো বেসিক জিনিসপত্র, এগুলো তো হাবি যাবে, এগুলো ম্যাথমেটিক্যাল ইটারেশনস, এগুলো পারবা। Certification linked to explorer of eyes to instance slides when we are looking directly into the slides source or we are dark cluster where covers to the lights from light. Okay. Okay. That's in the additional data. So what is the additional detail including safety precaution? So they haven't given a very specific safety precaution. If you don't write any safety precaution for this experiment, if you can think of any, if you stick to these other 9 points, you still can score 6 marks. Works for me. Keep distance from CD to screen constant. Like I said, D3. Keep n constant. N means what?
Order.
The order of the fringe. Beautiful. Method to identify same order. Example, identify the zero order and count the number of maxima to where h is measured. So you have to say that. Equation to determine example small differential getting formula with lambda as subject. Equation to determine lambda. So তোমাকে ওই এক্সপেরিমেন্টের ল্যামডাটাকে সাবজেক্ট করে ইকুয়েশন দেখাতে হবে। সো আমি ডিফারেন্সিয়েশন গেটিং ইকুয়েশন মানে হচ্ছে তুমি যদি ইয়ংস মডুলাসের ইকুয়েশন বলো তাহলে তোমার লিখতে হবে হচ্ছে ল্যামডা ইকুয়ালস টু x বাই ডি। শুধু x বাই ডি লিখলে আবার ঝামেলা, x বাই ডি লিখলে ঝামেলা হচ্ছে এখানে a কি x কি d কি এগুলো তুমি মেনশন করতেছো না। সো তখন তোমাকে আবার এগুলা কোনটার মিনিং কি সেটা লিখতে হবে। এ হচ্ছে সিক্স সেপারেশন।
এটা তো বলে নাই, জাস্ট বলছে ফর্মুলা লেখার জন্য, ওটা কি বলতে হবে তাহলে?
ইকুয়েশন লাগবে না, সো বলা লাগবে না, বুঝছি। ল্যামডা ইকুয়ালস টু x বাই ডি মেনশন করবা, অথবা যদি ডিফারেন্সিয়েশন গেটিং বলো তাহলে ল্যামডাকে সাবজেক্ট করতে হবে। তার মানে হচ্ছে d sin থিটা ইকুয়ালস টু n ল্যামডা লিখলে হবে না, ল্যামডাকে সাবজেক্ট করে লিখতে হবে। সো ল্যামডা ইকুয়ালস টু d sin থিটা ডিভাইড বাই n, এটা তোমার লেখা লাগবে, তাহলে তোমাকে মার্কস দিবে। Yeah, I've seen it. It's almost 10. I'm going to close the class pretty soon. ক্ষুধা লাগছে to be honest অনেক। এরপর বলছে হচ্ছে use intense light source or collimated light source. আচ্ছা, collimated কি জিনিস তোমরা অলরেডি জানো। Collimated basically makes sure that the light source is parallel, so it cuts off all the angled light rays. So why there is an underline in the use word? Use is a really important word. Weird. Perform experiment in a dark room. Yes. Clean surface or CD or check that the surface has there are no scratches. আচ্ছা, এটা একটা ভালো জিনিস, এটা আমি বলতে ভুলে গেছি।
এটা না হলে কি হতো?
এটা না হলে যেটা হবে
ইউনিফর্ম
বলতেছি আমি, দেখালেই বুঝবা। এই যে আমাদের যে প্যাটার্নটা আছে, we want the variation of the pad differences to be created from this slight variation of the CD surface that is underneath the polycarbonate plastic, which is the basic structural transparent plastic. If there are some scratches over here, there are some ups and downs over here, this individual indentation will also give you some variation of pad difference. Whenever there are no scratches, the light enters through this surface as a flat surface. So this is uniform for every single layer. But let's say if there is a scratch over here, but there is not, and there are other random scratches over here, each of the places where the light will enter through a scratch, it would enter through a different angled surface. এখন তো অ্যাঙ্গেল একটা, এখানে যেটা স্ক্র্যাচ পড়ে ওই স্ক্র্যাচের যে ভি শেপের বা ইউ শেপের যে একটা সারফেস থাকবে, ওই সারফেসে ইনসিডেন্ট অ্যাঙ্গেলটা ডিফারেন্ট হবে না ফর দ্যাট লোকাল রিজিয়ন।
মানে উপরে সেম থাকলেও পরে ডিফারেন্ট হয়ে যাবে।
Exactly. So this is going to give you some some messed up view for your pattern screen.
এক একটা লাইটের জন্য এক এক রকম হয়ে যাবে।
Exactly.
জি স্যার।
So you should preferably avoid that. Detail on measuring H, example measure to the top and the bottom of the maximum and average. আচ্ছা, এটা একটা ভালো জিনিস, এটা আমি বলে নিই তোমাদেরকে। সেটা হচ্ছে for the bright fringe that we are working with, other than trying to locate the exact center of this thing, they are proposing that we should measure the all the way up to the very top and all the way to the very bottom of that fringe and take the average of this thing. This is actually a good thing, which I did not say, wasn't in my mind. Makes sense. And then finally, illusion is valid if it's a straight line with a y-intercept.
জি স্যার। স্যার বুকলেটটা কি ফ্রাইডেতে কালেক্ট করতে পারবো?
হ্যাঁ মানে কালকে যদি অ্যাভেলেবল হয় কালকে পরে জিজ্ঞাসা কালকে করতে পারবা অনেস্টলি সো
আচ্ছা প্রতিদিন কি একই টাইমে 2টার পরে?
ফ্রাইডে তো 2টা তো জুমার টাইম, ফ্রাইডে হলে তো একটু পরে হলে ভালো হয় মনে করো, কারণ আরেকটু পরে বলছি কারণ হচ্ছে দ্য ওয়ে ইট ওয়ার্কস, আমার এমপ্লয়িজরা মনে জুমা করতে যাবে, তার জন্য পরে আসবে ভাত খাবে, সো ফ্রাইডে হলে 3টা পরে হলে ভালো হয়।
আচ্ছা আচ্ছা
Kids, thank you
Sir,
very much for those who still stick to for the up to 10.07. I really appreciate this. Good night.
স্যার কালকে 2টায় না?
হ্যাঁ কালকে 2টায় 2 p.m.
আচ্ছা
onward.
স্যার, ওকে স্যার।